external lighting system for the yard, and this was the transformer. When it showed up just one day and the transformer, the lights weren't working anymore. And after taking a closer look, I decided to open up the transformer. Couldn't get it to power any of these lights here, so after some effort I was able to open it up. You can see some of the marks there, but I was able to get it to pop off. And this is a Better Homes and Garden transformer used for their low voltage lighting system. Turns out, I guess the reason why it was so cheap at Walmart was because they were no longer producing them, so I couldn't find a replacement. So I went ahead and pulled this apart. You can tell here as we take a little closer look, pull this out, you can see the burnt mark. You see it very well here. So we get you a better look at it. Well, that's kind of hard to see it close. See the burn mark right here though. So this is where it takes in the AC voltage, runs it into here, runs it through the beginning of the stage of the transformer. It looks like the wire burned out. I went ahead and cleaned it out with some baking soda, vinegar to get the corrosion off, and whatever else was had kind of adhered to it. But long story short, the result of it was it no longer worked. So you can see the back side of the circuit board here as well, right here. See how it kind of also burned up slightly right here, and that affected its ability to work. So anyway, I pulled it apart, looked at the back of this. You can see this is a 18 volt DC 1.95 amp transformer, class 2, which just means it doesn't have the third prong that you normally see on outside sockets. So I went and found this other transformer that I have that I had kept. I usually keep most of my transformers, and I need something that was 18 volts and could run at least 1.95 amps. Here's a 3-prong system here. You see this one was replacement, could be a replacement. It was 18.5 volts, so it's within half a volt, 4.9 amps, so it could handle a lot more than 35 watts. You want to figure out what your transformer can handle, take a look at the voltage, multiply by the amperage, and you get essentially the watts. So this was a 35 watt transformer, and this one is a lot more. And at 18.5 volts times 4.9 puts us at 18.5 times 4.9. Sorry. Times 4.9. It's a 90 watt. So using one of these other transformers, we can actually increase the capacity of our line up to a point. There's still the internal components of these lights that can be a limiting factor. But anyway, that's that right there. So we went ahead and took, you notice that these sockets are what are used to combine, to basically connect these lines. This line here, this is another example of a socket, and there's a seal or a gasket that goes between each of these ties, and that keeps the water out. So I wanted to keep this transformer's tie and use it. So I went ahead and did that. I went ahead and cut off this from the bottom of that. It comes out right here. You can see the 2 lines I cut here. Pulled that there, and I took apart. Find here. I took this. You can see this is actually the transformer end, and it's not the same as this one here. So I went ahead and cut the wire here, pulled it apart, and got this. I did try for a while trying to connect these wires here to this here, and ran into some difficulties, so I went ahead and just pulled the wires all apart. You can see I've connected them now with alligator clips. And then I got my voltmeter here. I was able to determine that indeed I was generating 18.5 volts off of this transformer. And when I did that, it worked. So let's take a look. Just gonna plug it in here. See? There it is. You can tell, we can pull this here and take a look at what we're doing from a voltage standpoint. I'm gonna do that here and we'll take a look and see this. Gotta get it to, sometimes I wish I had more than one hand, but I don't. So, see, there it is. 18 and 19 volts, which is fine so far. Usually there's some sort of buffer, you know, they can handle so much voltage, but that should work. 18.5 volts would be fine for this application. Anyway, I'll get back to you once I get these things connected together and show you how I made those waterproof and ready to go for outside. Okay, you can see we've gone ahead and get it to zoom in here. Went ahead and soldered those together. It's not perfect, it's not great either, but it is holding them together, and it's holding them pretty strongly together, so that's good. You can see that there, those two wires are now soldered together. So that basically connects our transformer with the port that connects to the light right there, and it does work. I just tested it. So now what we're going to do to water seal this is use Plasti-Dip to create a plastic barrier around these two wires, and we'll go from there. Okay, I've gone ahead and Plasti-Dipped it. You can see here that it's shining out, but that's some Plasti-Dip there, so get in the sunlight and get a better view of it. And that covers both those connections there. Went and sprayed it over again just to get a better, more glossy finish to it. But it's not as perfect as a wire, but it should keep it waterproof, and that's the goal. So let that hang there, let that dry till it's finished, and we'll move on. Okay, as you can see, we got it working now. Lights are back on. See that? I'll show you what we have here. So you see the attachment here between the wires, connectors, and here's our soldered piece that we've connected those two wires together, and here's our power supply now. Keep it out here, should be okay. It's underneath the overhang and protected from the water and stuff, but it is a sealed unit, which is good, so it should be okay hopefully there. And it runs to a extension cord that runs to a timer. Use that for our lights, but we'll get rid of this extension cord and use a different extension cord, a little shorter, maybe a better colored extension cord here in a little while, but just wanted to show you how that worked out.